So, to continue talking about our financial models, we are now looking at, I think you noticed in the last example, the difference between compounding 12 times per year and compounding 365 times per year was only 21 cents, right? And I think if you could imagine if we compounded 1,000 times a year, that yeah, it would probably be a little bit more than $1,161.83, like a tiny bit, but not much. You're kind of coming up on a number, a limit there, of how much that compounding, the number of compoundings matters to the problem. And I think I promised back when we started learning E that there was a financial application of E as well. And here it is in continuous compounding. So the formula for continuous compounding is the amount is equal to the principal times E raised to the RT. Okay. Now all the variables are the same. A is still the amount, P is the principal, E is not a variable. Remember, E is a number. R is the rate in decimal form, and T is the time in years. So these are the same variables. And notice that this formula is actually the same as the other compounding formula, except all the stuff in the parentheses is replaced by E, okay? And that is that number that helps us approach. Imagine if we compounded our interest instead of daily, so 365 times in a year, instead of 1,000 times a year, what if we compounded it all the time? You know, every second, no, every millisecond. Okay, it doesn't just keep giving us more money because remember, we're dividing that interest rate by the number of compoundings. So it approaches that certain amount, and that's this formula. Okay, so to finish that off, then, that same problem, the information above, we've been using it for several examples. So to find if it was continuous compounding, we take our $1,000, multiply that by E, raised to the R, which was 0.03, times T, which is 5. Okay, so yeah, it's really pretty simple because all the big thing in the parentheses is just E now. Okay, if you multiply that out in your calculator, remember you have an E button. Let's just go ahead and look at that and do that together. Might as well. Okay, so let's see if I can pull that up a little farther so you can see the buttons too. Oh, that looks good. Okay, so we're going to do 1,000 and then times E, and you're going to go second natural log. So second ln is E. It gives you a little exponent there because E usually has an exponent, and then 0.03 times 5. Again, if you have an older calculator, when you do the caret, if it just gives you like it just gives you an open parenthesis, you want to put both 0.03 and 5 in that parenthesis. In my calculator, I don't need to do that because I can see that everything is up in the exponent, okay? There we go. So I got $1,161.83 again, but my after the cents is a little bit more than the last one, but really it's very negligible. Okay, so we got 1,161.83 again.